If you just find C if B is not C is the J is over J B C is the minus 30 to J G. Understand? B C 嘛 P relative to C. Oh, yeah. Okay. Maybe you have to attend the class earlier. I'm the class 10 minutes before. This is the first question. Her Marcus is T C J. Yes or no?
Yes.
T Marcus, how much is T Marcus?
Minus 30. D max is equal to 80.
50, right?
Yes.
You get 80. Your answer, yes or no? You get 80. So you, I give you a color. Yes or no? The maximum torque is 50. Yes, in this segment, the torque is 50. For this segment, the torque is minus 30. Why did you get 80?
80 is greater than
80 just 80 is a load. Is a load.
Yes.
Yes, so is 50 plus 0.01 Yes or no?
0.2 loves it.
2 is diameter,
Yes.
C is radius. Diameter is 20 millimeter. Yes or no?
Yes.
The formula, in the formula, C is radius. Is half D.
C is radius.
Yes or no? C is half D. So 0.01. Look at each answer. Yeah. Top. Yeah. That's what he's about. Common Marcus is tall Marcus. Over yes or no?
Yes.
Some students read common Marcus is C 5 over L.
When do you
The formula is red, but for this soft is not red. Why? Why?
Loves it.
No.
Charlie, have you
Before.
looked at C?
What
The equation is also same.
Wait. Suppose
Last year I didn't know.
suppose I draw a line like this, is not. So 50 in this segment is in this direction is A. In this direction of the deformation, the line from here to here, the line from here to here, so is not a straight line. So this formula just can use for if there is no atom. If there is no atom, is certain, is good. Understand that? If there is another node, the formula is not right. But for this segment, gamma matrix is C phi L. L equal 3
So what is the
is right. For this segment, gamma matrix is C phi. Is phi C B is phi B A over 2 is right.
If you make the summation,
Summation is not inside.
if you add this one and this one, we will not get equal to T max over this.
Over T, yeah.
If you add this one,
This one is right.
B is C times 5 equals A. B is this part. Then this one is this part.
Yeah.
If you add, we will get to C.
CA is 5. 5 CA is I use the total but gamma C 这个 gamma medicine can because suppose in this diagram before deformation is where change like this is 2 segments. 2. But just the 4 more part is straight line. 4 more part is straight line. So you can use this formula. But it's not a straight line. So the formula can be used. Understand? So the gamma matrix for CB is more than gamma matrix for BA. So it is I'm not sure because C of the same, but phi are different. Yes, not. Phi CB, phi BA are different. So after you find the two values, select the biggest one is the answer. Understand? So this formula is not right in the problem. For the problem.
So we have to use that formula.
Use this formula tau equal to gamma. Use this formula. This formula is good. Understand? Please understand.
I didn't
You didn't understand. You didn't understand. I explain for you. Look at it. What is C5? Is C5? Yes or no? The length is C5. The length is L. So it's gamma max. Because the line is a straight line. But for this problem, of the deformation, a straight line come to a curve is not a straight line, so we can use it. Understand? You know that gamma minus C phi CB is the length. Yes or no? L is the length. So gamma maxima is the angle. For this one, gamma maxima is the angle. For this one, the angle. So the maxima string, share string, the maximum share string is here or here. I don't know which one is it. I don't know which one is bigger. Yes or not? The biggest one is the gamma max.
Yes.
Understand or not? Okay. So we finished chapter 9, chapter 6,
Chapter 10.
chapter 9, chapter 10. I finished, but there are some other concepts I didn't introduce.
You can introduce them.
Okay. Yeah, normal sequencing. This kind of thing I didn't introduce. Before it's difficult. After I introduce chapters 12, I will come back here. Okay? Because it's a short. When I talk, it's a short. I didn't explain why the curve is a oblique curve. I didn't explain it. It's not. This part is explaining why the curve is a oblique curve. Why is a 45 degree. I didn't explain it because it is difficult. After I will introduce chapter 12. After I introduce
Chapter 11.
What was 11?
12.
11 only.
No. After I introduce chapter 12, I will come back here to explain this phenomenon.
Alright.
Understand? Because it is complex. So today, I'm going to chapter 11. Binding. There are 4 kinds of deformation in mechanics of materials. What are you doing? Absolutely. Shell deformation, elongation, bending, torsion. There are four kinds of deformation. Up to now, I introduced the first three deformation. For absolutely rod, we know how to find the stress and the strain. Yes, for the shaft, we also know how to find the stress and the strain. For bolt, we know how to get the shear stress and the bearing stress. Yes, so we just there are just one kind of deformation, bending. So I will introduce bending. If we know how to find the stress and the deformation for bending member, it means we finish the bending.
Really?
No. It's just the beginning. If you know how to find the stress and the strain for a beam, it's a beam, it's not. It means you must bending. Understand? Stress and strain, mechanical progress. Beam. What is a beam? Cylinder member that support loadings that are perpendicular to the longitudinals. In general, they have a constant cross section. We call this kind of member is a beam. It means for beam, the deformation is a bend. This kind of member is a beam. We call it is simple support beam. Is overhanging beam.
What's the difference?
What's the difference?
Yes.
You look at the figure, you can find the difference. Is the cantilever what? You can recognize the difference. Can you? Over, it's the roller. It's over.
So the difference is just the size of the
Yeah. The difference is very easy to find data. The beam is hard. What is the name for the beam?
Simple support.
Yeah, simple support beam. And the first that we have to find the internal force. Yes, sir?
Yes.
Suppose it's a beam. Is for given cross section. We imagine a cutter. Take one part to analysis. For beam, there are three kinds of internal force. So beam is difficult more than the previous three kinds of deformation. It's difficult. It's a beam for beam deformation is the important part for this object. And that because it is more complicated. There are shear force, the moment in general, normal 这个normal internal force is 0 in general, yeah. Is also is almost be 0, LP. Normal force almost be 0. You will find the result. Drawing V and M diagram is important because for being the same for shaft. If you want to find the top axis, it's not you will find the top axis. You have to find the top for every cross-section. Because the thermox is a T max C G. Yes or no? Where is the T max? You have to know. You have to know the top and every section. So for a beam is the same. If you want to find the maximum stress and force, we have to know where is the maximum moment or shear force. Yes, so we have to find the diagram of bending moment and shearing force. In doing so, we can find the maximum value, maximum bending moment. Yes, now maximum shear force. If you draw the diagram, you can know what is the maximum bending moment, what is the maximum shear force. Yes, right? So at first, we have to draw this kind of diagram. There is a overhanging beam. Is the loading. Is a distribution load. Is a concentrated load. How to draw the bending moment diagram and the shearing force diagram? And first, we have to decide how many regions should you consider. Should we consider it? And first, we have to know the beam sand convolution. For this, in this figure, it means it is a positive direction for shear force. Is a positive direction for bending moment. It means for B, suppose it is a B. Yes or not?
Yes.
A force acting on it. Yes or not? It will be information like this. Yes or not?
Yes.
For this bottom, it's bent like this. So it's positive. It's also bent like this. We call it positive. Bending moment is positive. But for shell deformation, it's like this. Yes or not? We call it positive. For this segment, it's like this. It's negative. Understand? For a small segment, for beam, in beam, they do cross section. If they right cross section relative to the left cross section is moved down, is downward. We call this deformation is a positive shell deformation. Understand? Otherwise, we know this kind of deformation is shell, is negative shell deformation. It is just a convolution. It's just a convolution. Same convolution. Yeah. So it's a positive internal moment. Yes or not?
Yes.
Yeah. If moment cause compression in top frequency, if the segment is deformation like this, it means the top part of the segment is in compression. The bottom fiber is elongation. It's not. For the beam, the loading is downward, acting on the beam. So we can imagine it's bent like this. It means the top material is in compression. The bottom materials is in tension. So where is the steel rod for the beam? Where should we place the steel rod in the beam? Because steel rod is good in tension. So the steel must place in the bottom part, because the concrete is weak in compression or in tension. Concrete is weaker in tension. If concrete is in tension, it is very easy to break. Understand? So in the top part, there is no steel. Understand? I will introduce the stress happened in the top part, the stress in the bottom part. We will find in the top part, the stress is negative. In the bottom part, the stress is positive. And positive means in tension. Negative means in compression. I will introduce it. Okay? At first, let's focus on internal force. Steps for determining internal force. Draw free body diagram of the structure. Calculate the support reaction. At first, we have to find the loading. Yes or no? Then method of section. Use method of section. It means immediately make a cut. To whatever the diagram of section from step 2 derive the equations for V and M. And then to V and M diagram use equations derived in step 3. The last step is check. Next, at first, let me introduce a simple example. Then we can know what is, how to do diagram. Here is what is the name of the beam?
Simple support.
Yeah, simple support beam. Uniform distribution loading acting on it. Yes or no?
Yeah.
Draw the shell and the moment diagram for the beam. And it was at the first step, we have to find the reaction for this beam. Because for any given cross section, the left section or the right section, there is a force. We don't know the magnitude. We don't know. So we have to find it.
Yeah.
If one of the part, all the loading alone, we didn't find the reaction. And suppose it is a cantilever beam. Suppose it is a cantilever beam is 50 Newton. Yes or no?
Yeah.
Make a cutter. For the right segment, all the loading unknown. So we didn't find the reaction. If you consider the left part, the reaction we didn't know. So you have to find the reaction. Understand?
Yeah.
So for this problem, suppose it is a cutter. For the right border and the left border, there are forces. We don't know. So we have to find the reaction at first. How much? How to find it? How to find the reaction? You know. In the first lecture, I introduced data because it belongs to statistics. Did you? Do you remember? Continue. You forget it. You can't forget it. Let's have a break. In the break, you solve it. Find the reaction. Okay? It's time for break. But in the break, you find the support reaction before me. Sniff. Your hand. How much is concentrated? At the first, you have to replace the distribution force by the concentrate in the first approach. The force is 10 kilonewton per meter. The length is 4 meter. How much is the force? Yes, but you just is travel.
Yeah, I can.
That's the force is travel.
These are large.
Do you know how to find the reactions for the problem? Yes, sir. Huh? Come to the blackboard. Can you write the answer on blackboard for me? No.
Then you can find the
I didn't find the bad moments. At first, I asked you to find the reactions. I just asked you to find the reactions. Before the action, find the reaction is belong to statics. I introduced it and the first lecture in this semester. It's our belief. It's hot. Your country have no wind. Yes, sir.
Yes, yes, sir.
Your country have no wind.